Yes. Good morning, good evening, good afternoon, everybody. Today I'm going to talk to you more about gravity strings. And this is going to be the next part. We're going to be focusing on velocity and acceleration of gravity strings. One of the beautiful things about the gravity string model is that it can explain acceleration and velocity. Now, since the time of Newton, he calculated acceleration, but he couldn't explain it. He knew that anytime you put two objects together, they'll come closer together and they'll speed up as they get closer. But he couldn't explain it. Nobody could explain it. I can explain it. So, but before we get into that, I want to sort of review the basic concepts of gravity strings. I covered this in a previous presentation, but I'm just going to summarize it and review it on a very quick basis. We begin with a particle, or any massive object. This could be a proton, electron, it could be a moon, it could be the Earth, it could be the sun, it could be anything. Anything that's an object, macroscopic, microscopic, whatever. Now, every object has mass. The mass is spread throughout the object. The gravity springs are attached to the mass spots, and they extend outward. They're very much like little vines that wind the way around. You might think of them as little strings, little spider webs. They're very wispy, very thin, but they extend out from the mass spot out into the air. Now these strings are all over the object. And one of the main concepts that's new about gravity strings is that they pull on their own object. You can think of this as a team of horses pulling a carriage, or dogs pulling a dog sled, or one of my favorites, a strong man pulling a locomotive. Any one of those things, you have individual power sources, dogs, horses, people, tethered together and finally tethered to the object. They're going to pull, like they pull the carriage forward or pull the locomotive forward, they will pull the particle forward. That is how it works. Now in free space, with nothing else around, it's just going to sit there. Why? Because you've got one team of horses pulling this way, one team of horses pulling that way. Net pull, 0. Goes nowhere. But when two objects come together, then the strings intertwine, then they have a specific direction. Looks like this. These are two particles, could be two moons. Gravity strings are intertwined together. And what happens then is that these strings will pull this particle forward, these strings will pull this particle forward. They're pulling themselves along the same gravity string line, which is always why it's straight. Another thing that you noticed was that gravity does not go up and down sideways motion, it's always straight. Gravity strings explain the straightness. I'm going to look at this closely again because when we talk about velocity, this is very important. So again, when gravity strings are intertwined, the mutual gravitational pull begins. When you have more gravity strings intertwined, you will have like two teams of horses or three teams of horses instead of one. What's going to happen? Each object is going to pull faster and faster and faster. So the more gravity strings you have pulling, the faster these particles will go. And that is important. Okay? So, basic concepts. Gravity strings pull on their own objects. The more gravity strings you have, the faster it will go. And this only will happen when gravity strings are intertwined.